Hi, everybody. I'm just going to make a short video about using Matlab in complex numbers. Well, how you represent a complex number has real part and imaginary part. For example, let's say that you want to define a number, a complex number z equal 3 plus j4. No, you write first the number 4 and then I. Let's see now what we'll get. All right, that's the way it's going to be written. All right. There's another way. If you want to print this number, you can write z equal and you write complex. And you open bracket and then you put the real part first, which is 3, comma, 4. And then you hit, here you go. You get it in the same way. Well, let's say it's given, the number 3 plus 4i was given, and you want to find only the magnitude of this one. Magnitude means 3 squared plus 4 square root. So you just write the real part, the absolute value, call it, for example, r. You write equal absolute, abs only, and you put z. So what do you expect? 3 squared plus 4 square root, you get for 5. Well, let's see what's happening there. Yes, here you go. And also there's an angle for this complex number because you have the real part, you have 3 and the imaginary 4. So you can find the angle by using 10. Let's say phase, let's write theta equal to, you'll use a10, and then you divide the imaginary part 4 by 3, and you get the angle in radian. Here you go. Let's say that you want to do the angle in degree. Let me just go back to the same one, and just before a10, you multiply it by 180 divided by pi and multiply it. So the radian will be changed to degree. Let's hit and see what's happening. Yes, it's 53 degree. Well, there is a command in Matlab, you can get the angle directly without doing the a10. Yes, you can. There is a called angle. Let's call theta equal, you just write angle, and the complex number is z, it was given. We expect to get the same result as theta here, 0.9273 in radian. Let's just hit. Oh, here you go. You got, so there's another interesting thing. Well, what about if you want to extract the real part from the complex number? You see here the number z is equal 3 plus 4i. The real part is equal 3 and the imaginary part is equal 4. How you get the real part? You just write x is equal. You can write anything, x you can call a, b, c, whatever the variable name. Anyway, real, and the whole complex number z. So I expect it's going to get me 3. Oh, here you go. What about if you want to find the imaginary part, y, which is should be 4i? Well, you write y equal imag, means imaginary, and you put z. Here you go. You got 4. Great. Now let's do something very interesting. I mean, that would be the last thing. How can you change the complex number from Cartesian to polar form? That's called Cartesian. When you say z is equal 3 plus 4i, that's Cartesian, it has x plus yi. And the polar form should be like a number and then multiplied by exponential angle. All right. So how do you do that? Well, there's a command. You just you open this square bracket, and first you put the angle that you want, theta, comma, and rho. It means the magnitude, and equal. You want to change from Cartesian, C-A-R, cart, to polar, P-O-L. That's the command that it should be written the right way. And then other bracket, you will write the value of the real part of the Cartesian complex number, and the second place you write the imaginary. Well, here I have 3 plus 4i. So the x or the real part is equal 3, right? 3, and the imaginary equal 4. I expect it's going to give me the magnitude and the angle, so you can represent it in polar form. So let's hit and see what's happening. All right, that's what you got. Theta is equal 0.9273. It's, I mean, we did it before here. And rho is equal 5. We did the first thing, the absolute value. So there is one command gives you 2 things. Now that's the last thing I'm going to do. What about if you want to change from Polar to Cartesian. It means the magnitude is given and the angle is given. Let me just give another example. Let's say R is the magnitude. I'm going to use the same thing we got it here. Let's say the magnitude is equal 5. All right. And let's make semicolon. And the angle, call it theta. Let's say in radian, should be in radian. I'm going to write the same 0.9273. So now I enter this data. I have the magnitude and I have the angle. So I want to get the equivalent Cartesian. You do the same thing as that. You say X, Y, you can call it anything. Let me call it something else. A, B. What does it mean? It means A is going to be the real part. B is going to be the imaginary part of the Cartesian form. And then you want to change from polar, P-O-L, to Cartesian, C-A-R-T, and then you open another bracket like that. And you put here, since you're having the, you are changing from polar to Cartesian, so you know the magnitude and the angle. I already know magnitude rho, which is equal to 5. I'll write to rho. It's already stored in this one rho. And the angle, oh no, I'm sorry. Theta should be first, not rho. So theta. Why I'm writing theta here? Because you have theta already. You got it. You can write the number. You are free. You can write the value of theta or just theta because I stored in theta, comma. And then you have rho. I have it here, rho, R-O-H is equal 5. You can put 5 rho. So here's put rho. And you close the bracket. And here you go. You are going to get what you expect. You're going to get the Cartesian, which is 3 plus 4i. Let's just sit and see what's happening. Here you go. So that was a fast thing for using the complex number. It was helpful. See you in another video.